So my name is Carlos Sanchez. I work for CloudBees, scaling the Jenkins platform. And that's my Twitter. If you want to ask anything, say good things about this talk. Otherwise, don't say anything. And a little bit about me. I'm also the author of the Jenkins Kubernetes plugin. And that's one part of the talk. And my background is open source, a lot of development in open source. Back in the day, Apache Maven, that probably you love or you hate, one or the other, but everybody knows today. And other open source foundations like not only Apache, but also Eclipse Foundation and other open source plugins like Puppet, and you name it. And I'm also part of the Google Developer Experts Group on this work we do with Google Container Engine, Google Cloud, and Kubernetes. So first question is, who is using Jenkins? Raise your hands. Okay, I can see pretty much everybody. Who is using Docker? Keep your hands up. Keep your hands up. Who is using Docker in production? Keep your hands up. Okay, a lot of people use Docker in production. Brave people here. An applause to this. So, for the last years, it was a lot like this, right? The solution, Docker. The problem, you tell me. Whatever your problem is, Docker is the solution, right? So. But then you have the problem when one machine is no longer enough, right? You want to run your Docker containers across multiple hosts and multiple environments, or you want to run on public cloud or private cloud, bare metal, whatever it is. And of course, you want this to be high availability, fault tolerance, so one machine is no longer enough. And there's a great quote by Kelsey Hightower. He's great speaker out there, and this really resonated on my head. Like, how would you design your infrastructure if you couldn't log in ever, right? Forget about SSHing into machines, trying to fix something in a specific machine. That's no longer possible. It's not possible if you have 50 machines. It's not possible if you have 100. But what if it's not possible even if you have 3, right? So think about that when you design your infrastructure. And the other big term on the buzzwords lingo today is microservices. So everybody wants to do microservices, and some people just think they can take their monolith and split it into microservices like this, but that's probably not what you want to do. So let's talk about Kubernetes. Who's using Kubernetes today? Some brave people there. Who knows what Kubernetes is? Okay, pretty much everyone. Well, like 70%. Let's be fair. So, short introduction. This is based on Google Borg, how Google runs their system at scale, how they run containers for like, I don't know, it was like more than 10 years. They run billions of containers every week. That before even Docker existed. So Kubernetes aims to run in your local machine, virtual, cloud, everywhere. And Google provides Kubernetes as a service in Google Container Engine, or GKE. But now you have a lot of other providers like Tectonic, StackPoint, CoreOS, and you can install it in your own with it's really easy to install through these third-party providers. And now, at last DockerCon, a couple of weeks ago, Docker announced that Docker Enterprise is going to support Kubernetes too. And I know that if you want to try Kubernetes, that you should use Minikube. It's like a small VM that you can run in your local machine, and it will allow you to play with all the APIs and do all the testing locally. So it's really cool for testing. What you get what's cool about Kubernetes is all the good stuff that you get for free. So you get declarative syntax in the sense that you say, oh, I want 10 containers of this running. I don't have to say run 1, run 2, stop 1, stop 2, or whatever. I just say run 10 containers. If a container dies, Kubernetes is going to start a new one. If a host dies and 3 containers die with that host, Kubernetes is going to spawn those 3 containers somewhere else. Another cool thing are pods, or group of collocated containers, and where you can basically say, I want to run this web server with this database, or this front end with this backend, and it will run those containers together in the same host with some syntax that basically sharing the network namespace. So you can always say localhost and talk to the other containers using localhost. And this is great for CI, and I'll show you an example. It's also providing you free, transparent persistent storage. You can say, okay, I just attach a disk to this container. I don't care where do you get the disk from once you have Kubernetes running. I just want a 10 gigabytes disk in this container mounted in some path. And Kubernetes is going to do that for you. And also transparent networking isolation. So you have containers that cannot talk to each other unless you approve it or not. So, and you can have namespaces in Kubernetes that basically don't see each other. So you could have development, staging, production, all running in the same Kubernetes cluster, all running maybe even in the same host, but they cannot talk to each other. Not through the network, not through the storage, not through anything. So that's something really cool. So a little bit on how it's structured. So you can have multiple nodes in Kubernetes. I think the limit is pretty high. I think last version was around 50,000 nodes. And you have masters that basically keep the state of the cluster. So these masters run etcd, and with kubectl, which is the command line, you talk to the API on the masters, and then the master runs the scheduler and a few other things, and it's going to manage all the nodes. From the point of view of what objects does Kubernetes provide you, you have the API server, and then on top of the API, you have different concepts, the base concept at the bottom is the kubelet, is a service that runs in every node, and is going to talk to the master and keep the state consistent. But then soon you can start using things like pods. That would be the basic unit in Kubernetes. So it's not one container, but a group of containers. I mean, it can be one, or it can be more than one. You can attach labels to every pod and pretty much to every resource in Kubernetes, so you can easily find things. And these pods, by default, they don't get exposed to the outside. There's no access to them unless you expose them explicitly using services. So the service is basically saying, the definition of a service is saying, I want to expose all these pods with this label or with some filter that I specify, and I want them to be exposed to the outside through this port, or find me a port to expose these services. So let's say you run Nginx server as pods, and you create a service and say, expose Nginx to the outside. And that will give you, depending on the type of service, you can get like a public IP, you can get an Amazon, you can get an Elastic load balancer. You can get a port in all the nodes that are part of your cluster. And Kubernetes transparently, everything that hits that IP or that Elastic load balancer or that port in the node is going to forward it to the right host and the right virtual port. And then there's other primitives on top of pods simplified the usage of ports. Basically, replication controller was the first one. Now there's different ones with a bit of different meanings. There's a stateful set. These controllers basically are the ones where you say, I want 10 pods. And the controller is the one that ensures that you always get 10 pods running. Because if you create pods by hand, if the pod dies, or if the host dies, that the pod is not restarted somewhere else. But if you create replication controllers, that replication controller is going to create the pods, and it's going to ensure that those pods are always running. There's also a bunch of other model objects like events, secrets, config maps that you can mount into the containers to specify configuration, secrets if you want to pass credentials. Events is you're going to get event stream of what's happening with all the model objects. And at the bottom is the service, how things get routed into the services. And on the left, you can see there's the namespaces. So namespaces basically allow you to group all of these, all on any of the objects into groups, and allows you to set quotas, allows you to set limits, allows you to set permissions, and allows you to also do the isolation if you want, to prevent things from touching each other. So you could have different namespaces for different environments, different teams, whatever. Another great quote that I like is DevOps Borat: to make error is human, to propagate error to all server in an automatic way. That's what DevOps is. So that's the beauty. When you have a very automated system and you touch something and then you realize you did something wrong, but it's so automated that it just basically you broke everything. Because, well, I have a version of that. There was some incident that I'm not going to talk about where somebody was touching the wrong thing, but we had everything so automated that kind of cascaded. So I came up with, if you haven't automatically destroyed something by mistake, is that you are not automating enough, right? At least once. Not in production, if you can avoid it, but at least once. So what's this whole Kubernetes Jenkins CI/CD talk about? So, well, you can run both Jenkins masters and agents. For those that are familiar with Jenkins, you already know that you can run masters and multiple agents, and you can run all of that in Kubernetes. I didn't mention it. At CloudBees, I work in something called CloudBees Jenkins Enterprise, a product that we built, and basically is running Jenkins masters and agents at scale. And everything runs on Docker containers, and we are launching soon this everything based on Kubernetes. Today we are using Apache Mesos, and Kubernetes is the next one really soon. So today, well, you can achieve infinite scale for whatever definition of infinite, or at least as big as your cluster is, where you can have the master, and the master can run whatever you want, but the agents, basically, you launch them dynamically. With the Jenkins Kubernetes plugin that I started a few years ago, you can basically say, every time a job is launched in Jenkins, it's going to go create a container for it. It's going to do whatever your job does, and then it's going to be destroyed at the end. So as long as you have capacity in your Kubernetes cluster, you can keep launching jobs to the infinite and beyond. So that's one cool thing. The other cool thing is it provides multi-container support. So you can have your job can be launched not just in one container, but in multiple ones that are part of a pod. And I'll show you an example. And it also has Jenkins pipeline support. Who knows? Who has used Jenkins pipelines or knows what they are? Okay. So Jenkins pipeline is a way to define your Jenkins jobs or CI/CD pipelines as code. So you store this in Git or not, but you can basically say what your steps. And all the examples I'm going to do is using Jenkins pipeline because it's like the best way, I think, to show that and to use, and because that way you have source control on your pipeline. And if you make changes or you change some parameters or whatever it is, it's always in source control, so you can always revert it if you want to. And it also allows you to have persistent workspace in your jobs. So what I mentioned before is you can attach volumes to pods. This could be NFS volumes. This could be EBS volumes in Amazon. This could be local storage, whatever it is that is supported by Kubernetes. You can do that and attach that to your Jenkins pods that are running agents. So let me show you an example. Let's create a new job. Let's call it Joker. And let's do it a pipeline. I'm going to do some live coding. I'm going to make some mistakes. Some are going to be on purpose. The other ones are not going to be on purpose, but I'm not going to tell you, okay? So I can define a very simple one. I can say pod template, and I can say label, if I can type, Joker. And I can say now, okay, on the node, Joker, execute, give me the host name. If I could type, you can probably not see that. Oh, that too big. So this would be a very simple pipeline where I'm saying, oh God. I'm not even saying what container to use, what image to use, nothing. And have you seen Blue Ocean for Jenkins? Raise your hands because I cannot see you. Okay, some people have. Well, is the new UI for Jenkins that you can install as a plugin, which is a lot more like, well, let's say it's not like 1980. So it allows you to do it's all Ajax-y and JavaScript-y and nice colors. And so this has run. I have no agents running, actually. I didn't show you that. I didn't have any agents running. Let me show you. So you see here, there's no agents running. So what happened here, it just happened too fast. It created a container, a pod. It launched this, and it gave me the name of the container where this was running. So let's do something a little bit longer. Okay. Let's Sage sleep 60. Let's rerun it. And I'll show you, well, not that one. So this has been running for 3 seconds, 6 seconds now. So this is, well, sorry. There's the Nginx, forget about it. I actually forgot to delete it. Let me delete it. Not this one, this one. The Jenkins 0 is the master that is running. This is the pod, the master pod, and I think I just rerun the last run that didn't have the sleep. Yeah, that's what I did. That was to see if you were paying attention, but nobody said anything. So let's run it again this time. And so I'm running all this in Google Container Engine, and I have a cluster that even has auto-scaling. That's another cool feature of Kubernetes. For some cloud providers, you can do auto-scaling. Basically, say, when you reach a point where there's no room to run more pods, just create more machines. So you see this is running now for more than 3 seconds. And it's going to disappear after the job runs. So this is sleeping, and so very simple. So this is my container engine cluster. And what Google provides you is just basically clicking, and you can just create a Kubernetes cluster whenever you want. Current size is 2. I have auto-scaling enabled, so I can set different pools of machines, and I can say, okay, this pool I want between 0 and 5 machines, or 0 and 50, and it's going to automatically auto-scale whenever there's more load. So that's the infinite scale. As long as your credit card has funds, that's going to work. So this is very simple. So what's happening behind the scenes is that by default, when I define a pod template, it's creating a container that is going to run the Jenkins agent. So I can run basic shell stuff, but not much more. So if I want to run, let's say, Maven, just to put an example that everybody loves, I can say containers, and I can say container template, name Maven. I can put whatever name I want. Image, that is important. I can say Maven Alpine, because we want a small OS. And 2 important things, TTI enabled true, and command is cut. This is just because when you run if you know about containers, you know that they are just processes. So if you run a container and the process dies, the container dies. So what I'm doing here is run this container from this image, run the cut command, and with TTI enable, that basically just hangs forever, because I don't want the container to die. If the container dies, the whole pod dies. The container goes away, the process dies, the container dies, and the whole thing dies. So what I want to do, if I didn't make any mistake here, I can say container Maven, and I can say sh mvn dash version, I think it was dash version. And so you see that there's no mvn in the other container. I'll just do another mvn dash version. And well, let's sleep here. So when this runs, what's going to happen is it's going to launch a pod that is going to have the Jenkins agent by default container. That's the agent that is going to connect to Jenkins and do the whole handshaking and sending information back and forth. But then it's going to have another container that has Maven installed. And in that container, then I can execute commands like Maven. And as you can see here, this container has Maven. And you'll see that the other container does not have Maven. And what happened here is that sometimes Jenkins will over-provision. This is a, let's say, either bug or feature, depending on what on whether you are the person that did it or not. So sometimes it will over-provision because Jenkins has this cloud API. That's what these plugins use, which basically it was done for the old days when you put. This is the same API that is being used for launching Amazon machines or machines in the cloud. So if you want agents to be spawned really fast, you have to set parameters to make Jenkins just check every second or 2 seconds for pending jobs. And because by default, it's going to check every minute. Because virtual machines were expensive, so you didn't want to start it, kill it, start it, kill it, start it, kill it. By default, what it does is checks every minute and doesn't kill them so fast. What I'm running with different parameters to kill them faster and start them faster. And what happens is that sometimes it may think, okay, I want to launch one. It didn't come up fast enough, maybe because it's downloading the image from the Docker Hub, or for whatever reason, it's taking a little bit more to start. So I tried to start one, didn't start yet. I'm going to start another one, and I'm going to start. So that's one of the things that people typically see as a problem, but it's not, because at some point they're going to go away. Okay. If we inspect it, well, it's like a drawback, but it's so kubectl inspect. Yeah, that's Docker. Describe and the pod. So you can see here that this is running 2 containers, the Maven container that comes from the Maven Alpine image, and then the GNLP container, that is the one that connects to Jenkins and does all the talking between the agent and Jenkins. So that's what's happening behind the scenes. And you can also see from the Kubernetes API, maybe this way better, what's happening is pulling images and creating containers and so on. And you see in the other container, Maven is not found. So now you may think, why do I care about this? Well, there's a very good reason to do this. So this is the example I show you, and this is the pod example that I also just show you, with a little bit more things in there. Okay, not that one. So if we go through this pipeline, I'm defining 2 container templates, one with Maven, one with Golang, and then I'm running a Maven build in the Maven container, and then I'm running a Golang build, which is like a makefile thing. I'm building Terraform, which is all Go, in the other container. So before, what you would have to do is you would have to create your Docker image that had Java, Maven, and Go, all in one image, because everything was one image, one container, one job. With this, what you can do is you can mix multiple images, multiple containers for one job. So there's no more need for you to create your own images. You can just reuse whatever is in the Docker Hub. So this will save a lot of work. And you don't have to keep updating them. Every time there's a new Maven, oh, I have to rebuild my Docker image to add the new Maven, or let's add this other tool. So instead of having one image that has everything, now you can just mix all of them. Okay. And another great example on how this is useful is, so I'm showing Selenium. Who's familiar with Selenium? Okay. So you will understand that to run tests in Selenium, it's a bit of a pain in the ass a lot of times. So if I want to run tests in parallel in Selenium, like using Maven, for instance, but in Chrome and Firefox, okay? I want to run Chrome tests, Firefox tests, and I want to run them in parallel because I don't want to wait for all of them to finish. I mean, for each of them to finish. What I can do today with Kubernetes is create one container for the Jenkins agent, as I always need. Create containers for Maven. Create a container for the Selenium hub, one container for Firefox, and one container for Chrome. So I could run this in 5 containers, and everything would run in parallel, which obviously would be a lot faster. What I'm doing here is adding another container, which will be another Maven. So I have one Maven for Firefox test, one Maven for Chrome tests. So it's actually 6 containers. So Jenkins agent, Maven for Firefox, Maven for Chrome, the Selenium hub, and then Selenium for Firefox and the Selenium for Chrome. So I'm defining all these templates, and with Jenkins Pipeline, the other cool thing that you can do, and I'm not going through that because it may get a bit confusing, but you can create libraries. So you don't have to copy and paste this over and over. You can create a library that is run Selenium, and it does all of this under the hood. So here I'm running a Maven where I'm going to run Firefox tests, another Maven container where I'm going to run Chrome tests, the Selenium hub, which is just basically the entry point for the Selenium, the different browsers, and the Selenium Chrome container. And you will see that there's a lot of environment variables. This is just because the images in the Docker hub are designed to run on Docker Compose. So what I told you before, that everything in a pod runs in the same network namespace, you can definitely see it here because both the Selenium Chrome and Selenium Firefox, by default, are going to try to use the same ports. So they're gonna crash. One of them is gonna crash. So you have to basically pass different ports as environment variables. This is just how the images were built back in the day. But if you want to reuse them, this is what you have to do. You basically have to go and tell them, okay, don't use the same port in both. This one use 5556, the other one use 5557, and so on. So that would be Selenium Chrome, Selenium Firefox, and where to connect to the hub. By default, the image tries to go to the hub DNS, and you're basically saying, no, just go to localhost, because the hub is in the same network namespace. So just go to localhost, and you'll find it. And what I can do is in this node, well, I check out the Git, and I can do the parallel step, and in parallel, I can say, okay, in the Maven Firefox container, run the tests for Selenium browser Firefox. So this is going to run in parallel with the other one. And in the Maven Chrome container, run the test for Chrome. So without having to create any Docker image, it's a more complicated example, but without having to create any other Docker image, I can run all these tests in parallel. And that's the cool thing about having pods. I talk about storage. You can have persistent volumes in Kubernetes, and any persistent volume that you have in Kubernetes, you can attach it also to your Jenkins agents if you want. So I can define a volume for my Maven repo, as an example. So I don't want to download everything every time in every job. So I could to create a volume just to hold my Maven repository, because everybody enjoys watching Maven download the internet, right? So if you look at the part where it says persistent volume claim, that's where you say, I want you to mount this Maven repo that I created into .m2/repository. And the same way you do this, you could just mount wherever you want, right? If you have a big data set in a disk in Amazon or in a disk in Google or in NFS or whatever, you don't have to just copy it over. You just mount it in every agent you have. Now let's talk a little about memory limits. So the scheduler, when you run anything in Kubernetes, a use case with Jenkins, you gotta make sure that the scheduler knows where to schedule things, where there's room enough, and you also want to make sure that your containers are not using more memory than you are allowed them, right? So I have an example here, and because you are very smart Java guys, because I do this at another conference and people that don't know Java is like a bit weird. So what I'm going to run is a container that this is a simple Maven test. And I'm running this, and you see this is using X amount of memory, and garbage collection happens, and then it goes back to around 180 or something megs. And you can see use, free, total, and max memory. And this is the cycle, right? You use memory, then garbage collection happens, you use more memory, garbage collection happens, and so on. Now, okay. What if I tell my Docker here, -m basically means limit the memory of this container to 210 megabytes. You've seen that it went over 200 megabytes. I mean, it went up to 300 at least. So what do you think is going to happen? Any ideas? Takers? Who says out-of-memory exception? Raise your hands. There's 2 people over there. Who said it's going to print an error, an exception? Raise your hands. No exceptions. Nobody wants an exception. Who says it's just going to die? There's 1 person. Everybody else is like, no comment. Any other takers? Any opinions? Nothing? Okay. So what happened is, well, this has been running. This is what happens. So basically, you get nothing on the text here. So basically, what happens is your JVM tried to use more memory than allowed by the Docker container, and the kernel has killed it. And how can you know that? Well, Docker bstsa, Docker inspect, and npm test. There's a very handy, but a little bit obscure flag here that says OOM killed true. So basically, the JVM by default is going to use typically 1/4 of the memory of the host, and is not going to be aware of what memory is available to the container. So this is what you're going to get. Your container is going to crash, and you're going to know nothing unless you look at the right place, or the kernel logs or something. And obviously, this is not really cool when you have a big cluster and you have to go looking into nodes. And this is especially important when you run things like Jenkins, where people just can run big builds or whatever, and things just magically disappear and they don't know what happened. So I'm going to run another example quickly. And I'm going to pass Maven ops XMX 210, so it matches. I'm saying limit the container to 210 megs, limit the JVM heap to 210 megs, right? So this is going to work mostly. It's gonna. The JVM now is aware of how much limit does it have, and it's not gonna use all of it. All the 1/4 of the memory is just gonna use 210. So as long as you don't have off-heap memory, you should be okay. Now, in the latest builds of the JVM, the JDK 8 and Java 9, you have an interesting new feature or flags here. Basically, you can tell the JVM, unlock experimental VM options, use a group memory limit for heap, and it will look at the container memory to set, instead of the host memory, to set the heap maximum. By default, also 1/4 of the container. So with max RAM fraction equals 1, all this, you just need 3 different options to do something that should be very obvious. You can tell the JVM, okay, use all the memory in the container for the heap, okay? And do not try to overuse and get killed. And that didn't quite work. Because you can still run out of heap. Because there's this max RAM fraction, there's other memory that is not heap, right? So depending on what are you running, if you run anything off heap or your JVM is using something off heap, you can still crash your JVM. At least this time you could get a more meaningful error. Now, I was cheating, obviously, because I was running Maven. By default, Maven runs with forking tests, so it creates a new JVM for the tests. So what happens if I disable that? What I was showing you is I disabled the forking, so everything runs in one VM. So what if I run in the default mode, where I Maven forks a new JVM for Surefire, which is the thing running the tests? Well, then you get another obscure error message. Well, you get killed. And here you get, failed, the fork VM, terminated with saying properly goodbye, the VM crashed. So if you fork a new JVM, this new JVM is gonna go and say, oh, do I have any parameters set for the max heap? No? Okay, then I'm just gonna use 1/4 of the host memory again. And this is what happens when you start spawning JVMs inside a container. And I think this should be the last one. There's an interesting option that has been around for a while, which is _Java options. This basically is telling the JVM, any new JVM that is created, use these options, okay? So you can spawn new JVMs, it's gonna look at this and it's gonna use those options. The problem is, if you spawn too many JVMs, well, obviously you need to set those limits right. So to sum up, memory is a mess when you run the JVM in a container. So you still have to be careful and extra careful on passing the right parameters to your memory, to the container, and to the JVM memory, so you don't make the kernel kill your containers and magically disappear. Well, so that's it. And what do you think? Well, this is all the new support that I talked about. What do you think happens with the CPUs? So when you set CPU requests in Kubernetes, for instance, that translates into Docker CPU shares. And when you say in Kubernetes, you have 2 things, right? I didn't mention this, sorry. You can set the requests for memory and CPU, and you can set the limits. So, or did I mention this? I'm getting old. So the request is basically, I want you to look for a host that has this space. The limits is, once this is running, don't let it go over this amount. So with CPU limits, what's going to happen is your container is not going to crash. Thank God for that. And it's just going to run slower. So when you set limits, the CPU quota is basically just limit how much CPU time your container gets, but it's not going to kill it. Okay. And you can also set that into your Jenkins pipeline, so you can basically pass all those parameters when you create your pod. And for the last part, I'm just going to show you how to do deployments to Kubernetes from Jenkins. So you can do, what I'm doing here is you're basically just running kubectl. So kubectl is the command line. I'm creating a pod that has the kubectl image, that's the container template there. So I run kubectl, apply, and my Kubernetes file. That will be the simplest way. You just run the command line that will talk to the API and so on. And there's other plugins out there that will allow you to read files from Git, and I'll show you an example of deploying. But these are basically libraries and plugins that will allow you to not use the CLI, but to do something else wrapped. So I have an example here. Okay. Actually, two examples. So this is going to deploy a Hello World application, very simple. And this is also going to show you how Kubernetes deals with upgrades. So let's look at what's happening while I'm running this. This is going to create a service, a Hello World service, that is going to expose a list of pods. And these pods are basically web server that just returns Hello World. The service does have this external IP. And once this gets deployed, it's going to tell me, it's going to create, I think it's 5 or 10 pods. And it's going to load balance across all of them. So still waiting for it to start. The slave is being created and so on. And there it is. I have a deployment called Hello World where I'm saying, oops, I want 10 pods. You have 10 now, up to date 10 available. So everything is good. And I can see the 10 Hello World pods here running. And I can query this. Right? Okay, I'm going to show. So it's just basically telling me, hello, Kubernetes 1.0. So I have created this deployment from Jenkins. And what I've done is a step of a manual upgrade step, maybe what you could do in your applications, where I'm saying, now I want to upgrade to 2.0. Do you want to upgrade it? No? Okay, let's go and say yes. And I should have done something else. Split the window. Here and here. You see that some of the requests are getting version 2.0, some of the requests are getting 1.0. So this is a small app, so it's happening pretty fast. But what Kubernetes has done, it has rolling upgrade all the pods in my deployment. And this probably happened too fast for us to see it. Let me do it again. So because my deployment says I want 10 always, it's always going to make sure that it's going to start a new one, kill the old one, start a new one, kill the old one. So that's another thing that you don't have to worry about with Kubernetes. So you see, I launch again the pipeline. Now the pods are returning 1.0. It's killing the old pods, the old pods that are 2.0, and starting the new ones that are 1.0. So this is, and it's load balancing, so some of the pods are returning, some of the requests are returning one, are hitting one pod, some of the requests are hitting other pods. Okay, so let me kill that. And just go through the last example. Let's support this. Croc Hunter. Obviously, you can use all the cool features that Jenkins already has. So I'm going to show you. Let's see. How can I automatically create things? So let's do a fake commit here to trigger a deployment. So I'm committing something to GitHub. GitHub is sending the hook to Jenkins. And you will see here at some point that is receiving the hook and is triggered a new pipeline. So here it is running. It's creating everything in Kubernetes. It's creating all the pods, the pod to run this. And then it's going to do a deployment of an app. And this is the Croc Hunter app here. So this is in GitHub. Let's see, Carlos Croc Hunter. So I'm doing the demo branch. This is a really cool application, really cool. The problem for the demos is when it takes a little bit more time for the containers to start. Everybody gets like, is it broken? Okay. Okay, so now the pod is started, it's just waiting for it to start. And we can see here. Yeah, so actually I'm deploying this to a new different namespace, Croc Hunter, to keep it separate from the other stuff. And there's nothing deployed there, only the service that will proxy to all the pods that I'm running. So, okay, whoa, this has failed. Let's run it again. This always happens. Never do live demos. Just follow my advice. So this is I have to show you the pipeline for this, obviously, because otherwise, what's the point? This is a more complex pipeline that you can find in GitHub. I'm really going. If you want to see it as a reference, I mean, I'm not going to go through everything here. I'm building a Docker image. I'm compiling Go very first. I'm checking out SEM. I am, okay, not here. Doing compilation and tests with Go in another container that has Go installed. So I'm doing the make. In another container that has the Docker client installed, I'm doing a Docker build and a Docker push but to gcloud registry, another registry. So I'm pushing the latest and the image that has the same tag as the Git tag. And then what I'm doing is deploying the services to Kubernetes. So I'm doing a go build, well, git checkout, go build, package everything in a Docker image, and then deploy that Docker image to Kubernetes. So let's see if this happened. Okay. So I have the compile and test here. It was a make file with Go, and I have built the container, and I have pushed it to my registry in Google Cloud, and I want to deploy. Yes, sure. So it has deployed to Kubernetes and has finished. I have 3 containers now, 2 creating, 1 running. The 3 are running now. So I have this deployment, 3 desired, 3 current, 3 up to date, and this external IP. If I go to that external IP, I have this really cool game, which is I can hunt crocodiles with lasers. What is more cool than lasers and crocodiles? Right? But of course, like the environmentalists didn't like this game. So I have to go and I have to change it and, you know, make it less brutal. So let's change it to, let's change the JavaScript here. Let's use a different JavaScript. Git commit no lasers. Let's push it. And with enough patience, this will, not that one, not that one. Oh God, how many tabs? Not that one, not that one, that one. Croc Hunter. So there was a push event, 6 seconds running. And again, this is all running on Kubernetes. And still I have the, here. So I still have the old version. This has been running for 1 minute. And the deployment is there. So this is going to go again. I committed something, made a change, and it's going to go again through the same hooks. Go compile, creating the Docker image, pushing it to the register. So this would be like the typical life cycle, typical pipelines for when you're doing like Docker image deployments to Kubernetes or to any other cluster. And this is gonna do the publish. Maybe have too many things running here. So kubectl get namespaces pods. No, that should be okay. Still waiting. And if I go to my container cluster, there's still 2 in the cluster size, 15 gigs of memory, 4 CPUs. All right, so let's kill. Okay, now it has started. So it's probably one of these. 37, yeah. You can also check the logs for anything here. So you can do kubectl logs -f, and you can see the logs for the agent. You see the agent, what the agent is doing, and if I wanted to see the logs for my Jenkins master, you can see Jenkins 0. Oh, I ran out of time. Oh, good. So I get, oh, okay. Well, this is publishing now the container, always happens in this last minute. And just, I hate to be the one running out of time. Come on, it's pushing. Okay, approve deployment. Once it runs pretty fast. So, okay, the old ones are getting terminated, new ones running, 9 seconds there. So is this the new one? No, this is not the new one. I'll refresh, and I should get the new one where I'm just launching fishes to crocodiles. So how exciting is that? Sorry. Okay. Spasibo.